Hello, everyone. Plan for this recording. I've had several people asking questions about word problems, and so I just thought to make it a quick recording, just giving a few more examples. I have them blank right now, so as I scroll down to the next one, I'll give you time to hit pause and try them. I think I have two. I have two per major topic, like age type problems and perimeter type problems, but then there's some just random not equations, word problems, situations, and I can't do every single possible way of writing a question. So I do have just singletons of those. But I have 7 questions total, and my guess is this is going to be about 20 minutes. So if you want to kind of scroll through, you can kind of see the different questions. All right, let's get rolling. So the first couple is age type problems. So when we look at these, first thing to recognize, I can only have one variable in all of these problems until we get to chapter 3 and 4. We are going to have one variable. So as I read this, I need to first decide what will my variable represent. So just quick reading, Joey is 20 years younger than Becky. In 2 years, Becky will be twice as old as Joey. How old are they now? So what's my two things I'm looking for? How old each person is. So I need to pick. Either assign my variable to represent Becky's age or Joey's age. Okay, so that's my first thing. I'm going to use Becky's age. So I'm going to use a B. Let me get this a little smaller. I'm going to use a B, and I'm going to let B represent Becky's age. Let me be more specific. Wow, sorry, that's horrible writing. I'm going to let B represent Becky's age now. So make sure you're specific. It's just for you. There are times when I do require that you define the variable, but for right now, this is just for you to know what your equation represents. So B is Becky's age, more specifically now. And I'm going to make a little table or a little box, however you want to say that. And I have Becky and I have Joey. And I have age now. And then continuing looking through, I know I want in 2 years. Okay, so making a little box or a little table of that. Let's represent or write an equation. We'll write an expression that represents each of these different situations. Becky's age now. Well, that's what I just defined my variable to be. I'll call that B. So if Joey is 20 years younger than Becky, in terms of B, how old is Joey? Well, he's whatever Becky is minus 20 years. If Becky's 50, then Joey's 30, and so on. Okay, so now I know an expression for now. In 2 years, Becky. So in 2 years, how old is Becky? Whatever she was, plus 2. How old is Joey? Whatever he was, plus 2. Okay, it's not too hard. Here's Becky's age. In 2 years, she's 2 years older. We're going to add 2. Here's Joey's age. In 2 years from now, we're going to add 2. Okay, but now we have the rest of the problem. Becky will be twice as old as Joey. So Becky's age is going to equal twice of whatever Joey's age is. I'm going to simplify that. Negative 20 plus 2 is a negative 18. In 2 years, B plus 2, Becky's age will be twice as old as Joey's age in 2 years. Do a little solve. B plus 2 distribute equals 2B minus 36. I'm going to subtract the B over here. 2B minus 1B is 1B. I'm going to add the 36 over here, and Becky is 38. So what was B? Becky's age right now. So right now, Becky is 38 and Joey is 18. In 2 years, Becky will be 40 and Joey will be 20. Becky is twice as old as Joey. Yep, in 2 years, Becky will be twice as old as Joey. And I would always do that. Take the answer you get, plug it back in, and see if the situation works. See if it satisfies the situation. All right, my suggestion, hit pause, give this one a try. I'm going to just keep on rolling, but if you hit pause, and when you come back, I'll solve it for you. Okay. As I read the problem, I have two people. I have Carmen and David. I have two options. I can make C Carmen's age or D David's age, or just make it an X and call it something. So I'm going to use C, and I'm going to call C Carmen's age now. And I'm going to be lazy and just write Carmen now. So this is my C, and this is her age now. And Carmen is 12 years older than David, so David's age is whatever Carmen's age is minus 12. Had I called D David's age, then Carmen would be D plus 12. And it really doesn't matter at all. Okay, you can do it more than one way. Okay, 5 years ago. So sorry, you can't read my writing, years ago. So 5 years ago, Carmen would be whatever she is now minus 5. And David would be whatever he is now minus 5. Don't make this part too hard. Just do what it says and worry about the rest of the criteria or the rest of the situation later. Just take what their ages are now and then either add 2 like on the last problem or subtract 5 or whatever this says to do right here. Okay, now let's write an equation based upon what the rest of the situation is. The sum of their ages is 28. 5 years ago, Carmen is C minus 5. 5 years ago, David is C minus 17, right? Combining like terms. The sum, so Carmen's age plus David's age has to equal 28. So for these age problems, write an expression for their age now, write an expression for whatever they're telling me, 2 years from now, 5 years ago, or whatever, and then write an equation. These are expressions, there's no equal sign. Then write an equation for the rest of the situation. Up above it was Becky was twice Joey. Now we know it's their sum that we're writing. Okay, and then just solve. I think getting to here is the hard part. I think the solving part's okay, but I'll go ahead and just solve so you can check your work. 1C plus 1C is 2C. Negative 5 minus 17 is a negative 22. Add 22 to both sides. Divide by 2. And right now, Carmen is 28, which means the David is minus 12, so 16. Wait a minute, how about I divide correctly? Wow. 50 divided by 2 is not 28. 50 divided by 2 is 25. So Carmen is 25 and David is 13. 5 years ago, Carmen was 20. 5 years ago, David was 18, and their sum does equal 28. I would always do that. Take your variable you got, plug it back into the situation, and see if we satisfy whatever criteria they're telling us it has to satisfy. Okay. If you can, hit pause and give it a try. Okay. If it's possible, I would draw a picture. And in this case, it is possible. Pictures really help me organize my data. And if I can't draw a picture, I'm going to draw a box or I'm going to draw a table or something to help me organize my data. So what's my data? The length of a rectangle is 3 times the width. The length of the rectangle. It doesn't matter which one I call my variable, but I think it's easier if I make W my width. And then my length is just 3 times whatever my W is. So the length is here, the width is here, and this is W, and this is 3 times W. Now, what if you said, well, I'm going to call this side over here L. Well, then my width would be L divided by 3 because it's 1/3 of that. Well, that's quite a bit harder because I have a fraction and all that terrible stuff. So I know I don't like that. So if you chose L first to be your variable, and I tried to write this in terms of W, it would make a fraction and that'd be hard. Not wrong, just hard. Okay? You can define either the length or the width to be your variable. And remember, I only have one variable. So if I called my length L, then I have to ask myself the question, what is the relationship of W in terms of L? What is the relationship of the width to the length? And the width would be 1/3 the length. And again, that's what's harder. So I'm choosing W to be my variable, and the length is equal to 3 times that. Okay? All right. So typically, this will be one way of you kind of knowing what's an easy way of deciding. The quantity that's being referenced. So the length of the rectangle is 3 times what? The width. This would typically be your variable. Not the one they're defining, but the one they're referencing, if that makes sense. And again, it doesn't matter, but that just usually is the easiest, not always, but that's a good place to start. Okay, perimeter. So if it's a rectangle, so some key things, it's a rectangle. So let's fill in the rest of the information. If it's a rectangle, the lengths are the same and the widths are the same. And perimeter is adding up all the sides. It's a distance around the outside. So just write an expression that says that. 3W plus W plus 3W plus W has to equal 96. Length plus width plus length plus width. I know there's formulas. You could do 2L plus 2W, but now we're just kind of getting fancy and just add them all up. Okay, 3, 4, 7, 8W has to equal 96. Divide by 8, W has to equal 12. So if the width is 12, my length is 3 times that, so my length has to be 36. Just quickly double checking, 36 plus 12 is 48, plus 12, oops, it's not 12, plus 36 is 74, plus 12 is 96, or 84, plus 12 is 96. It works. Okay. Number 4, draw a picture. The first side of a triangle. Well, which one's my first side? It doesn't matter. I'm just going to pick one of them. I'm going to call this X. The first side of a triangle is 12 centimeters less than the second side. So if I do what I said before, my second side I'm calling X, and my first side is 12 less than that. The third side is 4 times as long as the first. Remember what we said? This is my first, this was my second, and this is my third. The third side is 4 times as long as the first. So the third side is 4 times X minus 12. Perimeter, add them all up. X minus 12. The first side plus, I could slip a 1 in there. Plus the second side, plus the third side has to equal 27. Well, let's just distribute before I start combining like terms. My first step is to distribute the 4. 4 times X is 4X. 4 times a negative 12 is a negative 48. Now I combine like terms. I have 1, 2, 6 X's. I have a negative 12. A negative 48 would be a negative 60. I add 60, and I divide, and I get, what is that, 14.5? Let me grab a calculator real quick. Yeah, 14.5. Okay, remember what we just found? We found the second side. So the first side is 12 less than that. So there's my second. My first is 2.5. Let's get some units on here. Centimeters. And my third side is 4 times the first. So 4 times 2.5 is 10. Nope. Third side. Let's double check. Does my perimeter come out to be 27? 14.5 plus 2.5 is 17, plus 10 is 27. Okay, just to prove to you that it doesn't matter how we define our variables, let's do it another way. Because you may have picked a different side. I'm going to call my first side x. So my first side is 12 centimeters less than the second side. My second side must be whatever my first side is plus 12. And the third side is 4 times as long as the first. So the third side is 4 times as long as the first. This is my first, this is my second, this is my third. And the perimeter, x plus 4x plus x plus 12 equals 27. I went in the wrong order, sorry. I went x plus 4x plus x plus 12. It doesn't matter. Combining like terms, I get 6x plus 12 equals 27. I subtract 12 and 6x equals 15. I divide by 6 and x equals 2.5. So why are my x's different? I just said it doesn't matter. How come I got 14.5 here and I got 2.5 here? Because my x represents something different. X here is the second side and x here is the first side. So now let's check. Is my first side the same in both scenarios? Yep. 2.5, 2.5. They are. That's why it's super important for you to understand what is my x representing. Or when you write your equation, what does your x represent? So that when you solve, you know what you found. Did I find the first side? Did I find the second side? What did I just find? So that's why it's important to define your variable. Okay, now the second side is 12 more than that, so 14.5, which now matches up. And the third side is 4 times that, which is going to be 10, which is what we had before. Okay? All right. Number 5. 2 consecutive odd integers. Okay, we're switching gears. We're doing consecutive integer problems. Super common type of problem. And now from here on out, it's just different type of problems that are linear. And there's an unlimited number of topics. So we're just going to try consecutive integer problems. So what's a consecutive integer? So, odd integer. So 1, 3, 5, 7, etc. 2 consecutive even integers would be 2, 4, 6, 8, etc. 2 consecutive integers are just 1, 2, 3, 4, 5, etc. Okay, so the first thing we need to do is understand what that means and their relationships. 2 consecutive odd integers. So if I call x my first integer, what is the next? So if I'm calling x my first one, what's my second one? What is the relationship between every one of these numbers? From 3 to 5, from 5 to 7, from 7 to 9. Well, it's 2 more. So my second integer is 2 more than the first. Or if you called x the second integer, then the first one would be 2 less than the first. Okay, so there's my first integer. There's my second integer. The sum is 92. And solve. 2x plus 2 equals 92. Subtract. 2x equals 90. Divide. And x is 45. If my first integer is 45, my second integer is 47. Is 45 plus 47 equal to 92? Yep. Okay. Hit pause, give it a try. Okay, so Ace Truck Rental charges $54 per day plus 9 cents a mile. RJ's charges 38 cents per day plus, can't see my problem. Plus 13 cents a day. No, 13 cents a mile. How many miles will it cost renting a truck for 1 day equal the cost at RJ's? All right, sorry, I read that one a little clumsily, but I think we get the idea. So this per day doesn't matter because we're renting it for 1 day. So I have a fixed charge of $54. So I'm going to do Ace first. The cost for Ace, first question. What's my variable? Well, if the per day part doesn't matter, the per mile part definitely does. We're renting it for 1 day and it's 9 cents per mile. So I'm going to call X the number of miles. So how much does it cost? Well, it costs somebody $54 plus 9 cents a mile, 0.09 times however many miles we drive. Okay, there's the cost of renting at Ace. RJ's. It's going to cost us $38 plus 13 cents per mile. Okay, so there's my two scenarios. This is what it costs you at Ace. This is what it costs us at RJ's. For how many miles will the cost of renting the truck for 1 day be equal? So I want to take 54 plus 0.09x and equal that to 38 plus 13 cents per mile. Cost at Ace, cost at RJ's, when will they be equal? And solve. I'm going to subtract 38. I'm going to subtract 0.09. I'm going to divide. And we get, let me divide. Should be 4 or something. Yeah, 400. So X equals 400, put my units on there, miles. After 400 miles, the cost will be the same. And if you're doing this in real life, you would then say, okay, I think I'm only going to go 100 miles. So who's cheaper for 100 miles? Well, RJ starts with a cheaper initial cost, but it's more per mile. So if I'm going for 100 miles, RJ's cheaper. Ace has a more expensive upfront cost, but if I'm going a long ways, then it's cheaper to use a cheaper cents per mile. Okay, that's how we'd use this mathematical thinking in real life. People say, I never use this in real life. Well, you could if you want to, if you had something like this, which is super common. You have a fixed cost per day and a cost per mile. When you rent a U-Haul, it's just like that. Okay, there you go. Question 7, hit pause and give it a try. Okay, Philip has a total of 19 nickels and quarters in his pocket. He has a total of $2.15. How many of each coin does he have? So I'm going to break my rule, but then I'm going to unbreak it here later, if that makes sense. I'm going to call N the number of nickels. And I'm going to call Q the number of, no, I'm not going to do that. We're just going to stick with not breaking any rules. N's the number of nickels. Okay, so let's write the first scenario. We know that the number of nickels plus the number of quarters is equal to 19. Okay, so what is the number of quarters if I have N nickels and 19 coins total? What do we have for quarters? The number of quarters is equal to 19 minus however many nickels we have. If 19 is the number of coins and N is the number of nickels, then whatever you have for nickels, subtract that, and that's number of quarters. Okay, so there's our first scenario. Number of nickels is N, number of quarters is 19 minus N. He has a total of $2.15. So now we don't care about number of coins, now we care about value of coins. The value of a nickel is 5 cents. So the value of nickels I have in my pocket, or Philip has in his pocket, is 5 cents per nickel times the number of nickels. The value of quarters is 25 cents per quarter times the number of quarters, which is 19 minus N. The value of nickels, the value of quarters, and the total value has to equal $2.15. Okay, 0.05 N plus sorry, I had to hit pause for a second. 0.25 times 19 equals 4.75. 0.25 times N equals 0.25 N, and I didn't touch this. Okay, combine like terms. 0.05 minus 0.25 is a negative 0.2. We can do two steps at once. We're smart like that. I'm going to subtract 4.75 from both sides. And I get negative 2.60. Divide by negative 0.2. And I get N equals 13. The number of nickels is 13, and we just said up here the quarters is 19 minus that, so the number of quarters is equal to 6. I would plug the 6 back in and double check. 6 times 0.05 plus 13 times 0.25, and I would see, does that equal $2.15? And if you work it out, it does. So that's it. That's the end of the problems. So my takeaway or my key points to you is, when you are looking through or when you're reading through the problem, ask yourself, what's my variable? And there's only one. Once you know your variable, write your situation in terms of that variable. And like we said right here, if you choose something different than somebody else, you're going to get the same answer. It just, your problems might look different. So this setup actually looks way messier than this setup. But I did this one first and I got the right answer and it was okay. So sometimes your setup will be messy and harder than it would have been some other way. But that's okay. It still is going to come out. I wouldn't spend a ton of time trying to get the perfect setup, but I would take a little bit of time and just see, is there one way that's better than another? Once I got to here, I might decide, oh, I like this one better. Like I did on the perimeter problem for sure. If I had this as L divided by 3, now I got a bunch of fractions in my problem. And yeah, we can deal with fractions, but it's sometimes nicer not to deal with fractions. So just take a second and set it up. See if you could set it up different, but don't spend a ton of time trying to set it up perfectly, because it will work out. All right. I hope that helps.